This is an example of integration by parts, where we're going to have to use several iterations to find the antiderivative. That just means that we'll need to use integration by parts multiple times. And it's not immediately clear why that is, but we'll see here why that's true. So, integral x squared e to the x dx, we want to do integration by parts to evaluate this. We're going to let u be x squared and dv be e to the x dx. Normally, if we have an e to the x and we're doing integration by parts, we're going to make that dv, because if we now find v would just be e to the x. And then du will be the derivative of x squared, so 2x. So those are our pieces for integration by parts. And for our integration by parts formula, we're going to take x squared e to the x dx, which as it's written now is u dv. That's equal to uv minus integral v du. So we get u times v, which is x squared e to the x minus integral of v, which is e to the x, du, which is 2x. And I missed my dx here with du, 2x dx. But now if we look at this integral, we are still not able to integrate this. That means we're going to have to use integration by parts a second time. And for the second time, we'll let u be 2x and dv be e to the x dx again. Because again, that's going to make v just e to the x, and now du is going to be 2 dx. So repeating this process again, what we will have is integral x squared e to the x dx is equal to x squared e to the x, and then we're going to replace the second integral now with our new uv minus integral v du. Since we're going to get kind of a long or two-piece expression, and we have this subtraction, I'm just going to put those parentheses so we remember to subtract both pieces. And now using our second set of integration by parts pieces, we want to do uv, so that's 2x e to the x minus integral of v, which is e to the x, du, which is 2 dx. Let's simplify this a little bit. We get x squared e to the x. I'm going to go ahead and distribute this negative to both pieces. So minus 2x e to the x minus negative, so plus e to the x times 2 dx. I'm going to go ahead and pull that 2 in front of the integral. So we just have e to the x dx. And now we don't need to use integration by parts a third time, because this integral is possible to evaluate on its own. So we will get x squared e to the x minus 2x e to the x plus 2, and then integral e to the x is just e to the x. Since we're finding a general antiderivative, now we can add our constant at the end. Now in this case, we used integration by parts 2 times, we might need to use it 3 or 4 times. It doesn't matter how many times you need to use it. You can just kind of keep repeating this process until you get something that is possible to integrate normally, such as this final expression that we got here, integral of e to the x.